Hello, my name is Sweenus, and in this tutorial video I'm going to show you how to create a custom shader effect. This will be done using the Scene View extension and is pretty much all entirely in code. So that'll be C++ and HLSL. The effect itself is a post-process effect where all the colors except the one we pick, with a bit of range on either side of it, will be in grayscale. I'll mostly just cover what's needed to get the shader running rather than how the shader itself works, and then also just the way things connect. And if you wish to get straight to the code, you can find a link in the description to the Github Repository. Note that the helper functions are inside a separate plugin, but all the instructions for that are included in the README file. So in your plugin, you'll want to make sure that the module that is going to add the render passes is set to post-config init. This is the pass where pretty much all the shaders get loaded up. And then heading to your build.cs file, you'll want to add the public include path as follows. And then in your public dependencies, you'll want to include engine. And then for your private dependencies, you'll need projects, renderer, render core, and RHI. Heading over to your plugin's module CPP file, you'll want to include the following in the startup module function. This here is for loading the actual shader files. Once we've done that, we can create our Scene View extension class that extends fSceneViewExtension base. But before you'll want to make sure you've got the three following functions and the constructor set up like so. And then the rest of the functions you can see here dictate where along the render graph your passes will execute. So you can have it run before main rendering, right after, and then just before post-processing. And in this tutorial, I'm going to use the pre-post process pass, which is right before post-processing. This will run before your TAA and your post-process materials. And before we go into implementing the CPP side of things, I'm going to first create a way for the Scene View extension to be registered so that our shader actually runs, and then we'll actually work from the shader backwards all the way to the Scene View extension CPP. For this tutorial, I'm going to use a simple engine subsystem. It's just going to have the initialize and deinitialize functions. And then inside the CPP, we're going to set it up like so. And it's important to have a reference for the Scene View extension stored in your subsystem as well. For the actual shader files, we've got two different types. We've got a USH and then USFs. The USF files are going to include your actual shader entry points, and then the USH file are shader includes. So you will define your helper functions, your structs, and all that stuff in there. You don't have to, but you can, and then include them inside your USF files. One thing we absolutely need to include is the platform.ush. Although you can just include the common.ush, as that also includes platform inside of it. And then going down, we can see a bunch of different shader files that are included. Some of these are useful, others you might not need, depends on your use case. And then we have the example.ush, and that's where I've put in a bunch of the helper functions that you can see used in the main shader. So for our shader inputs, we have our target color, which is a float 3, and you'll see later how that will be mapped, which isn't how you might expect at first, but it does make sense overall. And then we have the texture 2D scene color texture. This texture will be the scene color with lighting applied. And moving on, we've got the actual shader declaration. It returns a float 4, which will get applied to the render target SV target 0. And then the input is just going to be the pixel coordinates. First thing we do is we convert the target color to CIE lab space. Ideally, you'd want to do this in your C++ side of it. That way you've only done it once, and then you just send up the lab values. This is just quick and dirty for the sake of tutorial. And we load our scene color texture. We don't need to use samplers for this, since it's just a one-to-one mapping, otherwise we would. And then I've got a define, and you'll see later on how this will be set. The top will get data from a struct that you can't see as an input, but it is brought in via the deferred shading common.ush. And this is so that I can get the unlit scene to test the color for. Otherwise, we'll just use the fully lit scene color instead. And then we use the delta E2000 function to get the perceptual difference. And if it's below threshold, which means that it's similar, we return the scene color. Otherwise, we return a grayscale version of the scene color. Now I'm going to work on the C++ side of it to register the shader and all that stuff. So the first thing we're going to do is we're going to create the parameter struct. This is for our inputs. As you can see, we've got the target color, which is an f vector 3f rather than a float 3. It's important to note that the capital F and then either of the vector 3D variants won't work. It has to be the small f. And then for our texture 2D, we'll just leave it as is. If you want to specify if it's just a single, dual, triple channel, you can put in your angle bracket float 3, 2, whatever, and it will work fine. And then we've got two structs, and these are the structs that you can't see in the tutorial shader as they're included in one of the included shader files. And all these files get set as we're about to add the pass to the render graph. And because we are rendering to a render target, we need to make sure that we have the render target binding slots macro added, otherwise it'll complain. And next we'll declare the global shader. So create our class, include the parameters, and then we've got two functions. They're both optional, but the modify compilation environment is where you'll set the define that was shown in the shader file. So as you can see, I'm using another macro, and then I'm setting it to 0, which means it'll use the scene color after lighting applied rather than the unlit scene. Going down, these are helper functions to make adding passes to the render graph easier for me. You don't need to use these, and I'll show you how you can work without them in the scene view extension CPP. Otherwise, it'll be implemented the same here as well. But one thing we will need to do is going into our CPP file, we'll want to add in this macro. And then we have our shader class followed by our shader location mapped to the virtual mapping that we set earlier. Next is the function that will get called in the shader, and then the type of shader. So moving back over to the scene view extension side of things, this is where we're going to bring everything together so it runs. And the first thing we'll see is declare GPU draw call stat, and this will be used later on in the actual render thread function. We just need to declare it here, and it's for either Unreal Insights or RenderDoc, I can't remember. You're going to want to make sure that your scene view extension constructor also calls the parent constructor with the auto register struct, otherwise it won't register the scene view extension. And then going into our override of the pre-post process path, we're going to start off with getting the viewport. This will be like 1920 by 1080. Next thing we need is the global shader map. And then below that, we have our render graph GPU stat scope using the declaration made at the top, and then one using just a string. So again, one's for Unreal Insights, the other one will be for RenderDoc. Then I have commented some of my helper functions, but below this is how you can do it without the use of my helper functions. So the first thing we're going to do is we're going to get the scene color without lighting applied. And I've tried using this without G buffers, but I couldn't get the right result. And then we'll get the scene color with lighting applied right after that. Next thing, we'll create our parameters, and these were defined earlier. The inputs for textures are fRenderGraph texture reference, it's just a pointer, and then we set the values for each. The scene textures and the view are for the structs that are included in the deferred USH. And then we're just setting the render target to be our fully lit scene texture. After that, we need a reference to the shader itself. And then we just call in the helper function epic made to include it all. The fRenderGraph event name will actually show up in Unreal Insights and RenderGraph as well for the actual execution part of the shader. Then also regarding performance profiling, for every curly brace scope you have, you can put in more RenderGraph event scopes, and then it'll create a stats kind of hierarchy of each one. And that's pretty much all you actually need. So then all you have to do is run the game engine, and you should see it take effect immediately. So now you can see how it looks with both the lit and unlit scene for the target color. And that's all for this video. In the next tutorial, I'm going to look at compute shaders. If you enjoyed this video and found it helpful, please give it a like and subscribe for more. As always, thank you for watching.